Assalamualaikum, I am BilawalZia and the topic which I am going to discuss is area and volume of similar figures and solids. In this video, I will be going over the method to learn how to differentiate between similar figures, how to calculate the scale factor of similar figures, how to find out a missing side of a similar figure by using the concept of scale factor, and lastly I will be going over how to calculate area and volume of similar figure if we know the scale factor. So let's start. Two figures are considered to be similar if they have the same shape, all their corresponding angles are congruent, and all their corresponding sides are proportional. What do we mean by congruent is that all their corresponding angles are equal, while the corresponding sides are proportional means that the scale factor of each and every corresponding side is the same. Similarly, two solids are said to be similar if they have the same type of solid, meaning the shape of the solid is the same, and their corresponding radii in case of sphere, cylinder, heights, base, lengths, and other parameters are proportional, that their scale factors are the same. In this slide, we will go in more detail what do we mean by corresponding angles and corresponding sides to be proportional. So let's see. As you can see, we have two triangles ABC and DEF. The side A is corresponding to side D. The point B is corresponding to point E, while point C is corresponding to point F. If this triangle ABC has to be similar or to DEF, then there are two conditions that it needs to fulfill. The first condition is that angle A should be equal to angle D. As angle A and angle D are corresponding sides, so their angles should be equal. Similarly, angle B should be equal to angle E and angle C should be equal to angle F. So the first condition is that all these corresponding angles should be equal. The second condition to be fulfilled is that the corresponding sides such as AB and its corresponding length is DE should have the ratio similar to the ratio of the side BC and its corresponding side EF, and lastly the side AC and its corresponding length DF. If the ratio of these three corresponding sides are equal, we can now conclude that these two figures or these two triangles are similar. Now the question arises, how would we measure the scale factor in order to determine that are the two sides similar or not? So the first step is that you should identify the corresponding sides. Like you can over here see two triangles A and B. Now this side of 3 cm is corresponding to side of 6 cm. Similarly, the side 4 cm triangle is corresponding to side 8 cm, while the side of 5 cm is corresponding to side of 10 cm. Now the first step, after done with this first step, the second step is to find or determine the corresponding ratios. So I will be putting the corresponding sides in a form of ratio and see if their answers are similar or if their answers are equal to each other or not. So the first side 3 by 6 should be equal to 4 by 8, which should be equal to 5 by 10. If you notice, these all come equal to 1 by 2. So 1 by 2 is equal to 1 by 2 is equal to 1 by 2. As these three sides have the same corresponding scale factor, we can conclude that triangle A and triangle B are similar. Let's try to solve another problem and trying to find out the similar triangle for the triangle in between. So the problem is that I want to find a pair of this triangle. Either it can be this triangle, this one or this one. So I need to find out the correct pair for this triangle. The best thing, as we just has learned, is to find out the corresponding ratios or the scale factor, and if they are same, we can conclude that these two pairs are similar. So first of all, let's start with triangle 4. Now the corresponding side of triangle 4 with the main triangle is 3 by 6 over 7 by 12 over 2 by 4. Now you can see the first ratio and the last ratio is same, but the in-between ratio is not similar. So this cannot be the option. So triangle 4 cannot be the option. Let's move to triangle number 3, and we see that is 3 over 4.5 should be equal to 7 by 10.5 should be equal to 2 by 3. Now as you can see that the ratio 1 and 2 seems to be equal, but again ratio 3 is not similar. The middle ratio is not similar. Let's try triangle number 2. So it's 3 by 6. Just remember that we are taking the ratio of the corresponding side. So 3 by 6, 7 by 14 and 2 by 6. So this becomes what? 1 by 2, 1 by 2 and 1 by 3. As you can see, in this case the last ratio is not equal to the first two. Now our last hope is triangle number 1. Let's see if we get the same answer. So it's 3 by 6, 7 by 14 and 2 by 4. And as you can see, all the corresponding sides have the same ratio. So we can conclude that the center triangle and triangle number 1 both are similar triangles. I hope this exercise makes the concept more clear. So let's do another problem to find the scale factor. Now you are given rectangle A with sides. You are given rectangle A with sides A and B. So rectangle A has 6 cm and 2 cm, while rectangle B corresponding side is 12 cm and 4 cm. So I am taking the side of the smaller rectangle. 6 over 12 is equal to 2 by 4. So we can conclude easily that the scale factor is 1 by 2. It's half. Let's try another problem. Now you can see over here that the rectangle A is in horizontal form while rectangle B is in vertical form. The first step is to rotate down this rectangle B in the same form as rectangle A so that we can choose the corresponding sides easily. Or the second way is that turn up this rectangle A in vertical form so it would be easy for us to find the corresponding sides. So if I redraw rectangle B, so this becomes 10 cm and this becomes 4 cm. Now it is easy for me to find the corresponding sides. Now 5 cm is corresponding to 10 cm because we know that rectangle two opposite sides have the same length. So it becomes 5 by 10, which should be equal to 2 by 4, and we can conclude that the ratio or the scale factor is 1 by 2. It can also be vice versa. If I'm starting with the bigger rectangle, so I write the first length 10 cm on top, 10/5 and 4/2. So you can again see the scale factor is same, 2 and 2. So it can be either way. I hope it is clear. Now let's go over this side. Now this question is interesting. In the previous question I told you that in order to identify the corresponding side, it is good if you have to redraw the figure again. Now if you see this problem, if you are lazy and not careful, you can conclude that 5 cm is corresponding to 15 cm, 3 cm is corresponding to 9 cm, and 4 cm is equal to 12 cm. But there can be confusion, so the best way is to, if it is possible, you can rotate this triangle. So let's try to rotate this triangle. And we are done. So if we rotate or redraw this triangle, this becomes something like this. 5 comes over here, 3 comes over here, and 4 goes on the top. Now it is easy for me to take the corresponding sides to find the scale factor. So also always remember that the scale factor for each corresponding side should be same. Then we can conclude that it is a correct scale factor. So 12/4, I'm writing a bigger side on the top. 12/4, 9/3, and 15/5. So this becomes what? 3 is equal to 3 is equal to 3. As all corresponding sides have the same scale factor, we can conclude that this is the same. These two triangles are similar. Now let's move on to finding the area of two similar figures. The theorem says that the ratio of the areas of any two similar figures is equal to the square of the ratio of any two corresponding lengths of the figure. What does it mean is that if area 1 and area 2 denotes the area of two similar figures and L1 and L2 denotes their corresponding lengths, so you can find the area by this formula. A1 over A2 is equal to L1 over L2 whole square. Let's try to solve a problem to make it more clear. You can see the two areas. Number one area of rectangle should be 3 into 2 is 6 cm square. Now let's say it is A1 and we give this name A2. Now according to this theorem, A1 over A2 should be equal to L1 over L2 square. Now the area of the first triangle, a rectangle, is 6 cm, while the area of the second is what we need to find. So let's find it by using this theorem. 6 over A2 is equal to, now the corresponding side L1, let's take it as 2 cm. So the corresponding sides of the second rectangle should be 4. So taking a square, it becomes what? 6 over A2 is equal to 4 over 16. If you cross multiply and you solve it, so you get area of the second rectangle to be 96 over 4, which is 24 centimeters square. Without having the second length of rectangle area 2, we are able to find centimeters. As this video can only be recorded up till 15 minutes, so we will stop over here. I hope the concept of similar figures and how to find the scale factor of two similar figures and area, how to find the area is clear. Thank you.